I found some practice problems on Kuta software under the Infinite Algebra 1 section. They have lots of worksheets, so if you haven't checked that out, you might want to look into that one. Before I get started, I want to make sure you know 3 things about graphing inequalities. And the first one, first of all, the objective here is to solve a system of inequalities. And by system, we're just talking about 2 of them or more, but hopefully just 2 for us. And to sketch the solution to each system of inequalities. So when we are talking about a solution, this is the first thing I want to make sure you know. A solution to an inequality system will be a region. If you're solving an equation, the solution is a single point. But if you're solving an inequality, you're talking about a whole region of solutions that will fit the pattern. So we're looking for a region. The second thing that you need to know about this is that you want your inequalities to be written in slope-intercept form. And if they're not, you want to put them in slope-intercept form. So you would want to solve the inequality so that it would be in the proper form. And that is in the form y equals mx plus b. And you can use equals, you can use an inequality sign there. The form doesn't change. Doesn't matter what this symbol is. This is the form you want it to be in. So m, of course, is slope. And b is the y-intercept. It's where the line of the inequality crosses the y-axis. So that's the second thing that you need to know, just background knowledge. The first thing is that we're looking for a region. The second thing is that we need both of our inequalities to be in slope-intercept form. If they're not, then we need to write them in slope-intercept form. Okay, the last thing that you need to know about this, I'm just going to go ahead and make a little table here to show you how this one works. So, well, that's not a very good table. Let's try that again. There we go. So, just a couple of things that you need to know. I believe 2 rows and 3 columns should do it. If the symbol you're dealing with faces left, you will shade below the line. If it faces right, you will shade above the line. And just bear with me a minute. I'll show you what we mean here once we actually have a graph to look at. Because remember, this is the region that we're looking for. Okay, and actually I need to adjust this just a hair. I'm sorry, I wasn't thinking. Imagine that. Let's just go ahead and put in I'm not changing the rules on you. I'm just changing the symbols. So if your symbol is just less than, you are going to use a dashed line. And I'll show you exactly what I mean. If it's less than equal to, you will use a solid line. If it is greater than only, you will use a dashed line. If it's greater than equal to, you use a solid line. So the equal to component makes a solid line. Just less than or greater than is a dashed line. Okay, so those are the background elements that you need to know, and you can pause this video if you need to. Just get that sort of fixed in your mind. You don't really have to memorize it because we can refer to it here at any time. But this is important stuff with the graph. And ideally, you would learn to do this when you graph inequalities. I'm just trying to combine it all in here together. Okay, so the first thing you need to check is the slope-intercept form. And both of these in number 1 are in slope-intercept form. So we're good to go on that first test. The second thing you want to do is go ahead and graph your inequalities. Now, I need to show you something on this. So let's go ahead and copy that first. And I think I'm going to use some color just to keep the pieces straight. So the first inequality I'm going to graph with a red pen. So I have y is less than or equal to negative x minus 2. So I can tell you using this sign, this less than equal to, that I'm going to be graphing a solid line because equal to is involved, and I will be shading to the left below the line because the arrow in the inequality is pointing to the left. So go ahead and figure that out if you need to. Okay, the next thing I'm going to do is graph the y-intercept. Now let's stop and think about what this means. This particular graph that I'm about to draw crosses the y-axis at -2. So I'm going to come over here to -2 and put a nice big point there. All right. Now, to get the actual line that you're going to graph, we need another point. We need to figure out where another point lies on this graph. And to do that, I'm going to use the slope factor. So I know that negative x is the same as negative 1x. But is it also the same as negative 1 over 1? Yes. Negative 1 over 1 is the same as negative x. It's just a fraction. And the reason I need a fraction is the key to this. Because this negative 1 over 1, that's my slope, means that I move negative 1 on the y-axis, rise, or sink, over run on the x-axis. Now let's get that in our head. We started out with this. Negative x minus 2. And I said, okay, let's put a 1 in there to have a constant in front of the x. That gives me the y movement, but I need to put that in fraction form to know how much to move on the x-axis, all without changing the value of my slope. So when I come back over here, this is telling me to move negative 1 on the y-axis. That's going to be down 1, and over 1 on the x-axis, negative 1, 1. It's just a coordinate in reverse. So I'm going to put a dot here. And then from there I could do it again. I could move down on the y and over on the x, and there would be another point. So this is where I want to draw my inequality line. And remember, it's supposed to be a solid line because equal to is a component. Now this may take me a few tries to get it straight. That's straight enough, I guess. So I'm going to make this be a line. And remember, I shade to the left of that line. So I'm just going to get a yellow pen and I'm going to shade over here to the left of that line because that's the direction that that arrow is pointing in that original inequality. So I have graphed my first inequality and I have shaded it appropriately. Okay, so let's get a different color and let's graph the other one. So I have y is greater than equal to negative 5x plus 2. So before I even get to the graphing and all that, I'm going to say that this will be a solid line. And I'm going to shade to the right. Okay, because the arrow's pointing to the right. So go ahead and figure that out before you start, and then you won't have to worry about it. So here is the y-intercept. That is positive 2. So I'm going to come to my graph, go up to positive 2 on the y, and drop a point. Okay, so here's slope. It's negative 5. That's the y movement, the rise. So I'm going to put a 1 under there, and that'll give me the x movement. So slope is negative 5 on the y-axis. That means I drop down 5. So 1, 2, 3, 4, 5, and then move over 1. And we're going to be there on that intersection. That's okay. That's actually a good thing. Okay, so then I'm going to try to get a straight line down through there. It's a solid line. So let's bring it down this way. I'm going to try. No, it doesn't want to snap to those points, but that's important. I need to get it as close as I can. That's pretty close, but let me try one more time. It's all about the angle. That's too far. I love that's pretty good. Okay, so let's make this be. And remember, this time I'm supposed to shade to the right of the blue line. So really, I just need to take out some of this shading that we don't want to include. Not all of it, sorry. So it's bounded by the blue line and it's bounded by the red line. And there's the region that we're looking for. That yellow region between the lines is where the solution will lie. So any point that is in this region is a solution of the inequality. This is not easy, okay? Do not feel discouraged. This is not easy. I'm going to stop this video and I'll come back and we'll work number 2.